All right, well, it's 1 o'clock. I'm going to cut my video off in a minute, so you don't have to look at me, but just wanted to introduce myself. My name's Jamie McCutcheon. Just a little bit about me and who's going to be talking to you today. So I'm a 92 graduate of Clemson University in civil engineering. In 1999, I founded SEDCAD Engineering to do primarily site development type work in the upstate of South Carolina. The company was acquired by Davis & Floyd about 2 years ago. In 2013, South Carolina adopted surface dewatering requirements for sediment basins, and I invented the Marley float skimmer and founded SW Products at that time. In 2018, we rebranded the company as Rymar Waterworks Innovations. I am a licensed engineer, South Carolina, North Carolina, and Georgia. I spent most of that of my career doing, like I said, site development related work with an emphasis on stormwater. Also, I'm a member of ICA, ASTM, and Southeast Stormwater Association. So again, I'm gonna stop my video so that goes, and we'll focus on the screen share from here out. So today we're going to go over skimmer sediment basin design. Our course objectives are for you to just basically understand what a skimmer is and why it is used. We're going to learn the fundamentals about skimmer basin design, and then we're going to get into some advanced skimmer modeling in SEDCAD and other hydrology software. This webinar is geared primarily towards Kentucky and specifically Louisville MSD. We understand that they have now started asking engineers to include skimmers on their projects. Just so you know, we have done a training with Louisville MSD with their review staff and their inspectors on skimmers. They asked us to come and have a talk with them. And so anyway, so they're very familiar with our product and us, and we're trying to help them as skimmers become more common in the Louisville area. So typically before now, you've probably seen most of your basins had a riser with an orifice probably at the bottom of the riser, and it pulls in a lot of mud from the bottom of the pond. Probably have a check dam in front of it. You know, the back side of this looks okay, but you can see how muddy this pond is. The front side is probably pretty much closed off or blinded off, but it is filtering some of the water that comes through there. So sediment basins with skimmer draw water from the surface or near the surface. With our skimmer, it actually comes just below the surface, from about 8 to 16 inches below. And what this does is allows the trash and debris that's floating on the surface to be retained in the basin, and the skimmer is much less prone to clog with this design. But it does drain it from the top down and allows more time for mud to settle and take the clean air water off of the higher portions of the water column as it discharges it. So most states have something in their construction general permit about surface outlets. And in most cases, it says something along the lines of, when discharging from sediment basins, utilize outlet structures that withdraw from the surface unless infeasible. And most of them have some kind of note that says basically, it's very rare that it's not feasible to do so. However, some exceptions may include cold weather if you've got frozen conditions where something on the surface would freeze. So there are about 30 states currently that have surface withdrawal requirements. This is probably not a completely current list, although we try to keep it pretty current. And we will say that the enforcement of those requirements varies greatly. Kentucky, we know, has had a requirement for surface draw in the construction general permit for several years, and obviously Louisville MSD is just now, starting to enforce that this year. So we see that in some places. Other states, once it goes in the CGP, it's been very strictly enforced, but it varies from state to state and even from MS4 to MS4. So you got three basic fundamentals of the sediment basin design. Those are volume, time, and flow rate. So fundamental number one on basin volume is basically a standard volume that appears in many regulations. 3,600 cubic feet per acre is a common one. Some other states require 1,800 cubic feet per acre, but just say you're in a state that requires 3,600 cubic feet. So if you had an 8-acre site, and typically that would be the disturbed area that this is calculated on, although some states require it on total area. Let's say 8 acres at 3,600 cubic feet would be a 28,800 cubic foot volume requirement. Some areas also require basins to have a permanent pool volume or sediment storage volume that is not drained by the skimmer. That's basically below the elevation of the skimmer outlet. And one thing to really note, we recommend you use the required volume and not actual volume when you're sizing the skimmer if you're doing it on a volume basis. So fundamental number 2 is dewatering time. So all sediment basins work by allowing time for the sediment to settle to the bottom. The time required will vary depending on soil type. If you're in a sandy area, obviously it'll settle out quickly, but silts and clays are going to be much more reluctant, take much longer if they settle at all. You're likely to at least have some discoloration even after a week or 2 of settling. What we see in many states is requiring 2 to 5 days or 48 to 120 hours, depending on the location, but that's kind of a common one. Some states have 2 to 7 days. Also note that your engineering judgments needed to balance the need for extended times for certain soil types versus the frequency of rain events. If you're in an area that gets afternoon thunderstorms every day and they may dump a ½ inch to 1 inch of rain, and your pond takes 5 days to drain, you may find out that it's overtopping rather than going through the outlet structure, and it would make more sense to drain it a little bit faster to keep that from happening. So the fundamental number 3 is flow rate. And so once you know the basin volume and dewatering times, it's easy to determine the required flow rate. Simply basin volume divided by dewatering time will give you your flow rate. Often if you're in a place that has a range of time, say the 2 to 5 days, you can establish a range of flow rates that you want to use. For example, our 28,000 cubic foot volume in 2 days is going to take a flow rate of 14,400 cubic feet per day, where if we wait 5 days, it's 5,760 cubic feet per day. So you can see there's a pretty good spread between the two. And a lower flow rate will often result in a smaller and typically less expensive skimmer for your contractor and client. It is important to focus on flow rate and not just skimmer size. To demonstrate that, I want to point out this study that was done by TRI Environmental. TRI was hired by the state of Georgia to help them when they're updating their erosion control manual. And they studied several skimmers. You see in this case, they've got 3 different 3-inch skimmers. Type 1 and type 2 have similar flow rates. The tank that they use is 4 feet deep, so 0 to 4 foot water depth. You'll see at a 1 foot depth, 37-ish GPM versus 70. So type 1 and type 2 were similar, but type 3, although it's a 3-inch skimmer, is nearly double the flow rate. And you'll also see that all 3 skimmers, even though skimmers are kind of assumed to be a constant head, constant flow device, nearly all skimmers have a flow rate curve. So there is a change in flow rate as depth increases. It's typically around a 25% increase. Once they get to around 4 feet, that flow seems to stabilize. You can see it's only a 1 GPM difference between 3.5 and 4 feet. So it's showing your stabilization there. But again, 1 3-inch skimmer flows at 90 GPM and the other 2 are about 47. So if you simply spec a 3-inch skimmer and didn't give any other information, it may not be what you want. You may get a skimmer that flows a lot higher or a lot slower than what you were assuming based on whatever skimmer type you were looking at. So to kind of give you an example, this is a comparison chart we have. The Faircloth skimmer is another popular skimmer out there. And so just to give a comparison, this is our retail prices for the Marley float, and these are the published Faircloth retail prices. But you can see often the skimmer size in the Marley is a little bit less than the Faircloth. Like our 2-inch is basically equivalent to his 2.5. Our 2.5 is about his 3. Our 4 is about his 5, and so on. And we just introduced new 6-inch and 8-inch skimmers. We actually have 2 8-inch versions, but you know, our 8-inch skimmer with a 7-inch orifice is very close to, or even a 6.5-inch orifice kind of splits his 8-inch skimmer at the higher flow rate of about 100,000 cubic feet per day. Our standard 8-inch flows 132,000 cubic feet per day. And we have a version of our 8-inch that would use an 8-inch pipe. Our standard 8-inch skimmer uses a 6-inch pipe, but we have a new 8-inch skimmer that uses an 8-inch pipe that gets almost to a 2 CFS flow rate, about 1.8 CFS, or almost 160,000 cubic feet per day. So we are seeing some basins for very large sites that may have 2 or 3 skimmers in them. And so we're hoping by making that skimmer available, it'll help to save the contractor some money and not have, you know, so many ponds with multiple skimmers. I will note quickly that this is a special order item. We don't see a huge demand for that. So it's about a 2-week lead time to get that shipped, whereas most of ours ship out within a day or 2. And just to kind of demonstrate the flow rate curve, this is the flow rate curve for a bunch of the different skimmers with orifice configurations. You can see the variation, but most of them, by the time they get to 4 feet, that last 3.5 to 4 feet is a relatively flat curve. So it's pretty much stabilizing by then. So I know we have primarily Kentucky engineers on the line today, but just to kind of give you a feel, I'm sure you work in some other states occasionally, what their standards are between you know, different states. So looking at basin volume, South Carolina has a 3,600 cubic feet per acre volume, where North Carolina, Georgia, and Ohio all have 1,800 cubic feet. Ohio is a state that has the additional sediment storage required, so they require another 1,000 cubic feet below the dewatering volume. And in Kentucky, you're required to calculate that, I believe. I know I've seen some plans that have just used, I think, a 3,600 cubic feet per acre. And you know, the different MS4s may have different standards, but I believe in a lot of cases they want you to use the Russell equation and calculate your soil type and base the volume on that. Surface area, some states use a 10-year storm, 325 square feet per CFS for 10-year. Others use a 2-year storm. If you run the math, they come out pretty similar. Some states have a maximum depth, but don't have a minimum surface area. And then again, Kentucky requires it to be calculated based on the soil type and a basin ratio equation. Principal spillways, that would be your skimmer and probably your riser structure. So anywhere from a 10-year to 2-year is pretty typical. Emergency spillway, that may be just a, again, emergency spillway built into the dam to catch those really large events. And that can vary anywhere from 100-year to 10-year requirements, with 25 kind of seeming to be the most common. Skimmer requirements, that really does vary from state to state. In South Carolina, it's 10 acres or more requires a skimmer, although some MS4s require them on smaller areas. Basically, anytime you have a sediment basin with an outlet structure, though, they're asking you to put a skimmer in. North Carolina, it seems that they're required on anything. We've seen some kind of large mud puddles that had skimmers in North Carolina. It's really hard to meet that 2-day time frame with those. Georgia's not actually required yet, although it technically is in their CGP. In the Georgia state requirements, they just say it's preferred, although a lot of MS4s now require it. Ohio is 10 plus acres, and Kentucky, it's basically 5+ acres. But again, if you have a sediment basin design with an outlet structure, what we understand is they're looking to see skimmers on those. If it's a sediment trap with a rock outlet, obviously it'd be hard to put a skimmer in there. So, and then dewatering time, most places have a range of 2 to 5 days. Georgia doesn't set a standard, they leave it up to the engineer. Ohio says 2 to 7 days. And again, Kentucky just says as required to meet 80% trapping. And when we get into the SEDCAD modeling, you're going to see that often you can meet the 80% without having to retain it for a full 2 days. So at least in the example we're going to go through here. Sorry, just checking on questions there. So we have developed a couple of design tools. So these are more geared towards when you have a standard volume and a standard time frame. So you input your information up top, describe your sediment basin. We've kind of got a reminder in here for your required dewatering volume. So whether that's disturbed area or total area, based on your location, you put that acreage in there and then put in the cubic feet required. So, if it's 1,800 cubic feet or 3,600 cubic feet or whatever that may be, this kind of gives you a check of what your required dewatering volume would be. And then when you go to build your basin, we allow you to put in a range, because most states do have a range of time. And we generally, even if the state specifies 3 days or something like that, we recommend that you plug in a range there anyway, probably at least 24-hour range, just to help with picking out what skimmer goes in there that makes the most sense. But you'll put in your pond depth. So your pond depth is the volume controlled by the skimmer. It wouldn't be your entire pond depth, up to the emergency spillway typically. And you put in your top length and width and your bottom length and width. And when you do that, it'll calculate a pond volume in cubic feet and gallons. That's just part of what we need for our calculation. But you want to compare this cubic feet to the required cubic feet to make sure they're similar. You don't need to go back and forth, get this thing down to 0.2 feet or something to hit it exactly. At least in most cases, we haven't had any reviewers that stringent, but you want to have something pretty close. What you don't want to see is have this calculated pond volume, 1.5, 2, or even 3 times your required volume, because by doing that, you'll end up picking a skimmer much larger than what you should. And that skimmer will discharge the required volume much faster than you want it to, so you don't get much settling time for that required volume. So when you plug that in, and I know you can't read this chart, but it'll run calculations for all of our skimmers and all of our orifice types. And then down at the bottom, we have a skimmer report page tab. So if you go down to that report page tab and click on it, it'll bring you to a one-page printout. And it'll give you all of your information and tell you what skimmers, based on your criteria, would work for that pond. So the top part of the page gives your information. It spits out what you put in as required volume and how much cubic feet, and gives that. And then lets you quickly compare the calculated pond volume to required as a check. It'll also give you the minimum flow rate for the maximum time as spec'd, and the maximum flow rate for the minimum time as specified. And then, because it is our tool, we give you out a chart. It'll calculate the drawdown time in hours for all of our skimmer configurations. So this is the skimmer size and then the orifice size. And then based on what time frame you set in the spreadsheet, it'll tell you which skimmers are appropriate to meet that time frame. So you'll see in this case, you could do anything from a 3-inch skimmer to a 6-inch skimmer, and figure out which one you prefer. Now the 3-inch skimmer is going to take, getting close to 4 days or a little over 4 days to drain. So you may not want to go with that. You may prefer to hit something that's closer to the 2 or 3 day time frame. But you'll also see that, if you say you chose the 4-inch skimmer and you got out there and it was draining too fast or too slow, you could easily change an orifice to allow it to adjust in the field with a really simple change, which we'll show you in a minute. We have prepared some generic skimmer basin details. We have several different versions. These are available on our website for free to download. They're in CAD and PDF. But they allow you to set your criteria over here as far as the minimum pond volume. Again, that may be 1,800 cubic feet or 3,600 cubic feet. The surface area. Big thing is it lets you set on your detail the dewatering time range. So you can set that whatever you feel comfortable with if your state doesn't specify one. And then down here at the bottom, we give you a data block to put in for your basins. Again, your basin volume, you want to make sure you're using the required volume and not the provided when you size the skimmer. The surface area, you just want to make sure you meet the required meets the provided. Outlet invert, barrel size, spillway, elevation and width, etc. And over here we have the skimmer size, the skimmer orifice diameter, skimmer manufacturer, so you know what skimmer version you're basing that on. Over here we have is an equal allowed, yes or no. Most of the time that's going to be yes. We encourage everybody to be on an equal playing field. However, there may be some times where you've got a site that you must have, that you really want to make sure you've got a precise flow rate and you need to use the one that's been set. Or you can just set this minimum or maximum flow rate. And in that case, let's say you specified a Marley and the contractor said they want to use a different brand. Well, as long as the flow rate for that skimmer falls within this range, it's already been approved by the reviewer. So it's a simple kind of shop drawing review, not a full, resubmittal, redesign kind of thing. We have a very similar tool that works when you have a permanent pool. So really the only difference in these tools is you've got a line up here for your sediment storage volume, and then you've got a line for your required dewatering volume. The rest of the tool works basically the same, and the chart kind of works the same too. So based on that on the calculated pond volume and time frame you set, it'll tell you which skimmers are appropriate to use for that site. And we have a basin detail for that as well. This basin detail adds this sediment storage volume and dewatering volume here. It adds the required sediment storage up here. Everything else is pretty much the same. This version has the permanent outlet structure, kind of riser setup, whereas the other detail I showed had more of a temporary outlet structure detail. So just a couple of things. I know, at least I think skimmers are kind of new to most people on here today. So some things to be aware of if you haven't seen them installed. So this is a pretty decent installation. It's brand new. The baffles are in. It's got a little pad for the skimmer to sit on, but you'll notice it's holding water here. And the skimmers, because they set the pad on top of the graded, the skimmer's not going to kick in until you got 6 or 8 inches of water in the pond. So what you want to do is make sure that your details call out for a little bit of a depression for that pad to go into. And so the skimmer sits down as much as it can if you want the bottom of the pond to be dry. Now you may want to have some undercut for some sediment storage, which is perfectly fine. You just know that the pond may hold a little water in that case. And a lot of engineers do that, but just something to be aware of when you're doing your design. Something to also be aware of is contractors sometimes really blow it. And so you can see this one doesn't make much sense. They've actually got the little side valve open. So the skimmer's not really doing anything anyway. And this skimmer should float up to at least somewhere in here. And obviously with that pipe, it's not going to go very far. So, and you typically don't need your big stone riprap spillway when you have the skimmer. It doesn't hurt to add a little protection to it, but the skimmer's going to float above that in most cases anyway. So you're not really trying to filter water through it, except on the very small storms that maybe come in without much time to settle. The other thing you'll notice is contractors, at least in our area, don't do a very good job of maintenance. And if you ever see vegetation growing out of the skimmer, there's a sign there's probably something wrong. So if you're doing weekly or monthly site inspections and see some issues, need to point them out, make sure the contractor is doing that. This particular skimmer had a root ball that was pretty much blocking all the flow. So this pond was holding water for weeks, not just days. And once they removed the root ball, it started flowing again and started functioning a lot better than it had been. So now we're going to jump into what I think, or at least I hope a lot of you are interested in, is some advanced skimmer modeling with SEDCAD. This is going to focus on how to model a skimmer in SEDCAD and hopefully show you how to get through the permit process a little smoother. So this is an actual site that we've done. So this is an existing warehouse facility. They want to add a new building. So this is existing conditions. Proposed conditions are going to be to add a new warehouse building here. We're putting in a detention pond that's going to also act as our sediment basin during construction on this backside. On the sedimentology map, the green area is basically the disturbed area that's going to, or most of that's disturbed, although we're not disturbing the asphalt, but the area to the pond, the red area is being bypassed or going a different way. There's about 10 acres total going to the pond and only about 3.3 disturbed acres going to the pond. So this is our sediment basin plan. So we call out for the skimmer, call out for the baffles. We have our limits of disturbance. We do have a rock outlet here where we're discharging onto the adjoining property to slow it down and get it stabilized before it leaves. Also have an emergency spillway, you know, in the event that it tops the skimmer or the riser. So in SEDCAD, first thing you're going to do, and I'm going to assume here a lot of you are probably already using SEDCAD or familiar with it. I will say that if you're not, or if I need to go into more detail with something or help you with a specific problem, please feel free to reach out to us by email or phone, and we'll be happy to schedule a quick Zoom call and kind of walk through any specifics. So this one's going to be a fairly simple, you know, one watershed, one basin kind of design, and we understand they get a lot more complicated. So anyway, for us, we have a type 2 storm. Local regs are a 10-year, 24-hour storm event for sediment design, basin design, and our rainfall for 10-year, 24-hour storm is 5.5 inches. We've got to input our soil particle size. So in this site, it's a CE is Cecil. So it's pretty much the entire site is Cecil, either B or C soils. Especially all the disturbed area here is actually a Cecil D soil. So we based our particle size distribution on our Cecil soil profile. Then you're going to get into your structure design. So the first thing you're going to do is you're going to input your network and your routing. In this case, our network was basically one watershed to a pond, so we didn't have to do any kind of real routing. We did have 2 sub-watersheds. So we broke out our disturbed area here. That's the 3 acres. You'll notice we've set a curve number of 86, which for us is a bare earth clay soil curve number here. We got about 7.3 acres, and that's a mix of some impervious, but a lot of grass, undeveloped. And so that's a 69 curve number, which was calculated. See the time of concentrations. Won't go in detail how you do that. I'm sure you're all familiar with it. And then you're going to set your other factors here. So your K factor is your soil erodibility factor. And there's a little chart. When you click on that, it'll tell you kind of pick one from it. Your lengths, your slope. The C factor is, you know, for our disturbed area, we set that at 1. That's a worst case, bare earth, you know, just freshly graded kind of site. The P factor, typically that's a 1 unless you've gotten in some other type of features, some diversion berms, grass swales, check downs that you want to factor in. But typically when we're doing a site like this, it's we're going to use a 1 as a worst case. And then we've checked disturbed for our subwatershed 1, which is our disturbed area. And so we're going to go into the basin design, or structure design. So when you get to this first page, you'll note if you're using baffles, most areas allow you to go down to 0% dead space. A lot of times we leave it at 20 just to be conservative. But you're going to go into your capacity and build your pond. And so, you know, most of those are going to be a stage storage input. So you got your contour elevations and your contour area at each stage. So you're going to use this data and plug in to your pond. Here's one important thing in SEDCAD. So when you do this, you want to set this stage increment over here to 0.10. And you're just going to put in your elevations and your areas, you know, based off of what your pond design is. And in this case, we've got an 8-foot deep basin. But set that stage increment to 0.1, and you'll see why here in just a second. So then you're going to go in and set up your outlet structure. Typically we used an enhanced perforated riser as our structure. So we put in all of our riser, you know, it's a 48-inch diameter riser, 7 feet high, barrel diameter, length, etc. Slope, mannings, you know, all that stuff. Top of the riser is at 849. We've got a number of holes per elevation at 1. But we're not coming over here and putting in any holes. So at the bottom of your riser, you've got a stub out for your skimmer. You're not going to plug that in here. You're going to leave all these blank. in the event you do have another hole in your riser that's maybe above your skimmer, if you've got to do some quantity control, obviously you plug that in. And with your riser, once you get to the top of the riser, SEDCAD is going to start calculating the flow into the riser over the top. All right, so the next step in order to model the skimmer, what you want to do is set up a user input discharge. So that's one of your choices. And so you just select user input discharge. And then when you do that, it'll come up and let you plug in the discharge rate at each elevation. When you look at our details, there's a box at the top that includes, I'll blow that up a little bit. So there you go. So we've got a skimmer with each orifice size in there, and we give you the flow rate in CFS and in cubic feet per second and cubic feet per day at 0.1, 0.3, and then every half a foot up to 4 feet. We also give you an average flow rate just in case you want it. That average is based on the flow between 1 foot and 4 foot, because that first foot is kind of slow and skimmer's just starting to kick in. So we base the average on the 1 foot to 4 foot depth. If the basin's deeper than 4 feet, you've got a couple of choices. You can either maintain that flow rate at 4 feet, because as we looked at the flow rate curves, it's starting to level out, or you can extrapolate it based on the last 3 data points. But you simply go in and by putting that 0.1 increment, it'll give you all these input points. You just plug in the ones that we give you. SEDCAD will interpolate between them, so you don't have to get the calculator out and plug all those in. We'll put those in there. And then at the basin, again, if it's greater than 4 feet, here they've just used the same flow rate all the way up from above 4 feet up to the 9 foot depth or 8 foot depth. One other option that you can use, if you download our design tool, again, we went over that earlier, and that's again available for free on our website, no login or sign up, but you can plug in a pond depth. And all of our design tools, we've come up with the flow rate curve for each skimmer. And so in this case, we're using a 4-inch skimmer with a 4-inch orifice. So I plugged in a 6 foot depth just to see what it would do. And here's my water level. And so I can look at my water level and see what my flow rate would be. So, at basically the 4 foot depth is 0.38, and by the time we get up to 6 feet deep, it's 0.41 based on the flow rate curve. So there is a slight increase, although, 0.03 CFS in 2 feet is a pretty minimal increase. But if you want to get accurate and put that in, that's one way for it to calculate it for you. So once you put all that in, your structure detail report will confirm all your inputs. So, there's all your riser information. It won't tell you up here your orifices like it normally would. It did calculate your peak elevation, your dewatering time. We'll note that that's 1.5 days, so obviously less than 2 days or the 48 hours that's required in a lot of cases. But we hit our 80%, check the box. We got 80.13, so we're good. And if you look at your elevation capacity discharge table, you'll see that the discharge matches what you plugged in for your user input for your skimmer. And if you look at as that table goes on up to 8 feet, it follows that till the top of the riser kicks in. One thing to note on the sedimentology, SEDCAD does not take into account the surface withdrawal. It assumes that the water is coming through the entire water column. So when you had the hole at the bottom, you were kind of getting a little benefit from that because it wasn't assuming it was all coming out of the bottom. But now you're getting a little negative that you're not getting the benefit of taking it off the surface. And so your actual trapping efficiencies may be, and in most cases probably are, slightly higher than what SEDCAD is calculating. So most states, and I believe Kentucky is the same way, require 80% trapping efficiency during construction. If 80% is not met, you've got a couple of options of trial and error. You can modify your pond, kind of keep going up in size on it. You can maybe reduce your skimmer size to get a little more dewatering time. Or you may just have to, add a check dam or forebay or some other small measure and then kind of add the two together to get the total for the site. However, we have had experience with some agencies, and I can't say Louisville MSD is going to do it or all agencies will, but we've been able to, in some cases, explain that SEDCAD does not factor in the surface withdrawal. and you know, let's say we're at 78.9%, and you've been beating on this thing and you just can't get it above 80 to check the box. Sometimes the agencies will accept that if you kind of write in an engineering judgment or engineering narrative to that SEDCAD does not factor in surface withdrawal and assumes it's the entire water column. Again, that's going to vary from MS4 to MS4. So the other thing that I'd like to run through briefly is advanced skimmer modeling and hydroflow hydrographs. This seems to be a fairly popular software. We're also going to touch on HydroCAD. And where this would come into play would be if you want to consider using the skimmer post-construction, which we'll get into a little bit at the end of this. So just going to run through this quickly, a couple of key points, how to do it. Basically, if you're going to use the skimmer, well, two things. If during construction you're required to do quantity control and show that, which is not a lot of places, but some places do require that, then you may need to do this. Or if you're going to leave the skimmer in and use it as your low flow orifice, the big advantage to that is, you know, a 4-inch skimmer is going to flow similar to a 2-inch orifice with a couple of feet of head on it. And so you get a similar flow rate, but you get a much bigger orifice size and a design that's, one, less prone to clog, and two, if it does clog, much easier to get to. So just a couple of reasons to consider leaving the skimmer in the basin. So this site, was a site we did in Greenville, in the city of Greenville, South Carolina. So it had about 5 acres. We had about 2.2 that's being developed, and it's going to a little road. There's no drainage on this road. There's a catch basin on the other side. So we wanted to do quantity control, so we're not releasing more water to this road during construction or post-construction than is there now for liability issues. And so again, pre-development was about 5.5 acres. In this case, it was a wooded site, I believe. So curve number was 59 and time of concentration close to 20 minutes. The post-development for the disturbed area, the undisturbed stayed the same. The disturbed area was about 2.25 acres, curve number again of 86 for bare conditions. Time of concentration just over about 7 minutes. Again, we did our stage storage inputs here, but you'll see when we did this, we actually did create a stage at each data point where we had skimmer flow rate. So we put in a 0.1, a 0.3, and then every half a foot. Obviously this was done as a demonstration. You may feel comfortable doing it every foot and just plugging in the skimmer flows from there. If you want to really get that flow rate curve down, you know, plug it in every half a foot. And again, the flow rates come off the detail. Again, we're plugging in the 4-inch skimmer on this one. And then when you build this, you're going to have your orifice A, which is your barrel going out. In this case, we had an orifice C, which was actually a 6-inch orifice, about 1.75 feet above the bottom of the pond. The top of the riser was at 961, so it's only 3.6 feet high. And it was a complicated outlet structure, had a rectangular weir 3 feet above the bottom. And then where we plug in our skimmer flow is over here under user defined. So again, this is manually input, user defined flow, just pulling it straight off the detail at each data point and plugging it in there. Again, hydroflow will interpolate between entry points. If the basin is over 4 feet deep, you can again extract, you know, keep it the same, extrapolate it, or you go back and use our design tool. The outlet structure looks something like this, so you don't see an orifice at the bottom. So this is where our user-defined skimmer flow would come in. You got your 6-inch orifice and your rectangular weir, your riser. And so if you look at the stage discharge curve, it looks something like this. So this is your skimmer flow. And we did a little highlight here to identify it as your green line there. So you can see a really small amount of the flow, and your 6-inch orifice kicking in, your rectangular weir kicking in, and then the top of the riser kicking in. So you can see your full discharge. And if you look at the discharge table, again, you'll see there's no discharge from anything but the user defined up until about 2 feet, and then it starts kicking in the others. So in this case, the preconditioned 2-year was like 2.3 CFS, They actually let us have a slight increase to 2.5 CFS, a 0.1517 CFS increase on the 2-year. 10-year was about a half a CFS decrease. We did look at this, and in South Carolina, you're supposed to have a 2 to 5 day drawdown time. We also did this one in SEDCAD and got our 80% without that, but if they had checked it, we only had 29-hour total time to dewater the basin. So I would say well below the 48 hours. And if you really look close, the pond didn't fill up to about the 12-hour mark. So really it was draining out in about 17 hours. And so for an example, and we also checked and the basin was basically full. So we didn't have much more capacity in the basin to slow it down. So we did plug in a smaller skimmer. We just to kind of run the numbers and see, and we got it out. So it's 66 hours to drain. And again, that's really from the 12-hour mark. So it's about 54, but at least we're over the 48-hour time frame. And again, it's getting a little higher in the pond. So it's going over, it's not overtopping, but it's more of it's going through the riser. And when you look at the flows, even though we put in a smaller skimmer, our peak flow for the 10-year storm went from up to 10.9. Again, before it was about 9 CFS, and now it's up to almost 11 CFS. So that wouldn't work. We'd have to have done some more design work with the pond to probably expand it or change some things in order to get that flow back down. But just want to demonstrate that a smaller skimmer doesn't always equate to a lower flow rate for the pond itself. Obviously, the skimmer itself is going to do that, but you may cause water to pond up and start going more over the riser and actually increase your peak flows. So I'm going to touch just a little bit on HydroCAD. So HydroCAD is another modeling program. It's very similar to HydroFlow. It's a little smaller company. Now that HydroFlow has been acquired by Autodesk, we don't see as many upgrades and changes coming out. One of the things we really like about HydroCAD is it has a lot of proprietary products built into it. So when you're building your pond outlet, you can pick on a user or special outlet structure, and it'll, these special and user defined outlets. And when you pick that, it'll come up and go to to this dialog box, and you've got a load from file button. If you click on the load from file button, it'll take you to a list of folders. And in there, you'll have the skimmers, the models, and the sizes. So this is actually our old models. We'll be getting HydroFlow to update with the new information soon. If you're a HydroFlow user and need that sooner, I've got all the Excel files I can send you. Be glad to share those. But HydroFlow, typically they do updates every month or two, so it should be updated in the next next month or two. But if you need it sooner, just let me know. I'll be glad to email that information to you. Again, you want to check your drawdown time. In HydroFlow, you go to this node report and see that what the basin was. In this case, we're getting out to 65, 66 hours. So we're meeting our 2-day minimum time frame. All right, so we're going to jump into a little bit of discussion about permanent use of skimmers. So again, what we see is the low flow orifices that we're having to do for water quality on the post-construction side really get clogged and hard to maintain. So this is a pond where honestly they had not done maintenance in a long time. It was a mess, but it was a bigger mess than we realized once we got into it. So I'm gonna back up. So this basin, you can see these orifices here, and you can kind of see it down here, but it looks like it's kind of drained out. But the only holes we could see were these that were like 4 feet above the bottom of the pond. When we got into doing some digging on it, turns out that there's supposed to be a 2-inch orifice about 10 feet below these. And again, they're about 4 feet above grade. So that means the 2-inch orifice is 6 feet below grade, and it had filled up with that much muck and junk and trash over many, many years. So we actually went in and modified the design of the basin. They were going to have to clean the entire basin out, which would have cost probably $75,000 to $100,000 to get in and do that work. But this was one of those rare basins that's actually a little bit oversized and had some more extra volume. So we closed in these low orifices. We put in some orifices a little bit higher, and we went in and put in a skimmer as the low flow orifice instead of the 2-inch orifice that was below. You can see it is sitting up a little bit, but this soil does perk, so it does drain out, you know, in a day or two. And we've monitored it on a regular basis. And they did start maintaining this pond more often. So the landscapers came out and cut all the vegetation, but did not get it out of the pond in time. And it got about a 5-inch rain in 3 or 4 hours. And you can see all this trash that went into the basin. Well, skimmer's sitting a little cockeyed because of all the trash in there, but it did drain it down. And you know, if it had clogged, getting to an outlet in there would have been next to impossible. So just kind of demonstrates the advantage of having a skimmer. You know, if it did clog, getting to the skimmer, you just pull it over to the side with a rope, or at least you can get to it with a little boat or inner tube. But you know, if this had clogged and it was 8-10 feet down below, a bunch of muck would have been nearly impossible to get to. And this structure is about 15 feet tall. And remember, on the inside, it's got another 6 feet. So it'd be really difficult to get that trash rack off, get inside, climb down, and get to that orifice to clean it out from the inside. So big advantage for maintenance to use the skimmer, even if it does clog, but it's also much less prone to clog. So this is another site that we worked on in Charlotte. It was a pond in a natural area, had built basically a dam across a stream. This was the outlet, so it was a little 6 or 10-inch pipe here. And you can see it was basically completely covered up, completely full of sediment. And we got it all cleaned out and went back in and added riprap ring. But every time it rained, because it was a natural area, we got a ton of sediment and debris accumulate at it. So we worked with the property owner. And again, getting it unclogged was nearly impossible because that's about a 6 feet deep of water and it's just not draining because all the debris clogging the pipe. So we worked with the property owner. We modified the design of this basin. We put in a structure and we put in a skimmer as a low flow. And then we had the riser as our, you know, higher storm events. The big advantage here in Charlotte was they were also eligible for some stormwater fee credits. And so by putting in this skimmer design, we got them a 95% stormwater fee credit, which translates to about $25,000 to $30,000 a year. And so even though this was not cheap work to get done, the fee credits paid for it in about 1.5 years, 2 years. And now that property owner is receiving a huge credit on their stormwater bills every year just for maintaining this. We've kind of kept an eye on it, keep watching it. It is in a natural stream, so sometimes if the flow rate's there, it has a little bit of a permanent pond, but if you get a couple of days of dry weather, it'll dry out. One thing we did find after about 4 or 5 years is the pipe here, we had put in an HDPE pipe and for UV, and HDPE started to bow and bend a little bit. So we've actually replaced that with a PVC pipe and just keep an eye on it. You know, PVC is probably going to deteriorate over 4 or 5 years, but it's not all that difficult just to replace a stick of pipe if they have to. But you can see how much trash and debris is still in this pond, but even with all this stuff, the skimmer's working really well and not clogging. All right, so I'm going to get a little bit of just about our website, just to know what we have available. So our website is rymarwaterworks.com. We welcome you all to go there. Like I said, for engineers, there's no login, sign up. We don't send you a bunch of spam. Honestly, I wish we did a little better at sending out emails on a regular basis, but we're working on that. So we have under the Marley Float page, we have our design tools. So you'll see this is the basic design tool. And this is the design tool with the permanent pool. Ohio is one of the states that requires that. And they actually asked us to come up with that to help them and help some engineers getting through their specs. Have a comparison chart on flow rates that we looked at. And then we have all of our skimmers. This is the 2, 3, and 4, but if you scroll down, you'll see the 6, 8, and our 8 with 8-inch pipe. We have it in PDF and CAD, and we have a cut sheet or installation instructions there. And if you scroll on down the page, you'll get to the skimmer basin details that I showed earlier. Again, those are in CAD and PDF, and you're welcome to tweak and modify those as you need to. This is our standard detail. So for example, this is our 4-inch detail. Again, it comes with all the flow rate information for each orifice configuration. And so the way the skimmers work, they'll have a little debris guard here. So basically a fabric debris guard that hangs down to kind of keep out trash and debris. This orifice plate has this little small hole in the middle. And so there's a little small nub that kind of sits right here that this fits over. And you just turn it so that the right orifice size fits over the outlet. And so in this case, you'd have a 4-inch outlet, and you'd have 3, 2.5, and 4-inch, 2-inch, 2.5, 3, and 4-inch orifices in here. So we have a 4-inch orifice, so you can just leave the orifice plate in there so they don't lose it and get the 4-inch full flow. Some of the skimmers have different sizes, and you just take the orifice out for full flow. But anyway, it's a really easy, convenient way to change the flow rate. So one of the biggest things about our skimmer versus others is it's an HDPE product. So it's all polyethylene or HDPE. It's all stainless steel or aluminum fittings. There's a little bit of parts on here, some couplings and stuff that are Schedule 80 PVC. So they're not 100% HDPE, but those are pretty minimal parts on it that are. And it's designed to be part of the permanent outlet structure and has no real moving parts, just this one-piece pivots. In the past, we had some issues with the skimmers twisting or turning. And so you can see that hopefully this video is coming through well, but you can see no matter what you do to the skimmer, it always becomes back level. So it doesn't twist or turn over. It's self-leveling, and that's one of the advantages of our new design that we just released this year. So, and again, in this picture, you can see that debris guard. We've actually gone to a fabric that's more orange. It's basically the same fabric, but it's just the orange color to kind of go with our branding. But it hangs down about 12 to 15 inches below the surface to keep the debris out from the skimmer. As you can see in this picture, it kind of shows how it hangs down basically to the bottom of the pipe. Has a vent tube. Again, this design really prevents clogging, really limits the trash that can get to it to clog it. And it traps the floatables in the basin and increases your sediment trapping efficiency. And keeps mud and debris from getting there. Also with our design, we're taking water in from below the surface. So in mild frozen conditions, I think it probably applied to Kentucky. I know it applies to South Carolina. You know, we don't get more than a couple of inches of ice typically, so it's going to continue to function in those conditions, whereas something directly on the surface may not. You know, we have some interest in Canada, and I can't say it's going to work in Canadian frozen conditions all the time, but I don't know anything that would do that. So, you know, as engineer, we ask you to specify the size of the skimmer and the orifice. Again, this is our 2-inch skimmer, so you can see the different, you know, it has this orifice, that's the little nub at the bottom that this fits over. And you can rotate this. You can go 1/2 inch, 3/4 inch, 1 inch, 1.5 inch orifice size, or just take it out for the full 2-inch size. So every model of ours provides anywhere from 3 to 5 flow rates in one device. And the saddle is held securely in place. It fits snugly down over that. And all of our flow rates are based on third-party testing. We also have our new 6 and 8-inch now available. We had to really do some work. We had a custom float made to be big enough to hold these in place and really function well. It's nearly unsinkable. I mean, this is a beast of a float that's going to hold it up. It's got built-in handles, making it easier to carry and installation. We've had some questions about colors, especially if they're going in permanent basins. So our 6-inch standard is orange, and our 8-inch standard is actually a black float. If you are looking at, say, a high-end subdivision and you really you know, want it to blend in the pond, or you're looking at doing something for somebody that's got a brand color. You know, if you're going to do something for University of Louisville and they want a red one out there, you know, we can accommodate you on those. We need a little bit of time. It's probably about a month lead time to create that and get it in the cycle, but it is something that is available, and we can work with you on the cost of that for special order items. One thing we're really excited about, and just a little bit of a teaser here, we have R&D underway to test a skimmer with filter media for post-construction water quality. So we're really excited about this. We're pushing hard to get it completed, but it'll be an add-on around the skimmer, and we'll have a specialized filter media that will be designed to not only remove TSS, we expect to hit easily above 85% TSS removal, but the media will also remove hydrocarbons, metals, and we're working hard to even include phosphorus and some other pollutants. So that's kind of the next phase of where we're headed, and super excited about it. Just, you know, working hard to get that completed, and we'll keep you informed as we do. So as we wrap up here, and it's just about an hour, I want to really quickly introduce you to some other RIMAR products. Really just one main product we have. It's called the VersaWattle, and this is our HS, or hard surface wattle. So basically what it is it's a fabric wattle that goes down. It's actually screwed down to the asphalt and concrete, but it's particularly effective where you've got, say, a subdivision, they haven't put the final asphalt course on yet, and you've got a lip here between your curb and your asphalt. So most of the time water's in the road and it's just going to run right past your basin to go in there. And so instead, our VersaWattle will, hopefully the video's showing, will catch the water, trap the sediment, and kick the water over the curb. So you've got relatively clean water. I'm sure there's some sediment getting out, but catching a lot of it there and keeping the water from bypassing. You know, we've had a lot of sites where water bypassed a number of catch basins, got to a low point, and just jumped the curb and blew it out. So it caused some major cost to do that. Then also, it's designed to be driven over. So unlike some of the other products out there that are maybe rubber filled or sand filled or rock filled that would burst when driven over, ours is foam filled. And so even though you drive over it with a dump truck, it rebounds very quickly and is back in use. So we've had these on sites in prototype testing for a year now, and they're, you know, even the original ones put in are still holding up and still working well. So that's it. We appreciate your time. Hopefully you got some benefit out of it today. See, we had about close to 20 people on. Many of you would like to receive continuing education credit. In order to do that, please email us at info@rimarwaterworks.com. We'll send you a very short, very simple, I promise, quiz just to confirm you listened in today, kind of validates your credit, and we'll send you a PDH certificate. And for all those that have stayed on and listened to us and would like, please email us and we'll be glad to send you a $10 Chick-fil-A gift card as well. We couldn't provide lunch to everybody in person today, but we want to still give you a true lunch and learn so you can pick up lunch later. So again, thank you very much for your interest in the Marley Float. Please reach out to us if we can ever be of assistance, and don't hesitate to ask if you have any questions.